What's up, everybody? Welcome to Electrician's Masterclass. Tonight we're gonna work on a sub panel. All right, we're gonna do the fundamentals of a sub panel, and what we're gonna do is we're going to go over everything that's in the sub panel and what it does, and I'm gonna break it down for you. All right. So right now we will have a question and answer also, where you can just put your comments up there and just ask questions as we go along. All right. So that's what we're gonna do. Okay. Alright, so the first thing that we're going to do is we're going to take this panel cover off, and we're going to get ready to work on it. Alright, so we're going to take it off like this. We're going to hold it as we unscrew it so nothing goes boom. Okay. Keep your arm up against it while you do it. Alright, you can see it pretty good, right? Alright. Okay. Alright, so we got 10 on this side, and we have 10 on this side. All right, this is a square D home line panel. All right, there's two different types, residential panels, and one is a little bit better. It's a QO. All right, and this one is a home line panel. It's called a home line panel with home line breakers. All right, so alright, so what it is this is a 100 amp panel, alright, and there's a breaker in here even though it's a sub panel, alright, and that breaker feeds this panel for the reason being that there's 8 units in this building, alright, where I'm working, and since this is 100 amp, most likely it's 800 amp service, so that means 100 amp each unit. All right, so the main is downstairs that shuts this panel off, but it's so far that you need to put a breaker in here. It can't just be like a main lug. You have to put a breaker in here because it's easily accessible. You could shut it off in an emergency. All right. So this is the cable, all right, that goes up, and then I guess it must loop and then go downstairs. All right, this is what we call SER cable. All right, it's a round cable, not the flat one. All right, and this is an aluminum cable that goes down to the main panel. All right. So just excuse me one second. Okay, so anyway, what we have here is, like I said, 20 circuits. You have 10 on each side. All right, and this is a single phase panel. All right, and these are your two phases right here. So if we get voltage, a multimeter, my bad, a multimeter, and we get this, we can see this multimeter here, we can get like, we can do continuity, we can do voltage, AC or DC, we can do amperage, AC or DC, and we can also read hertz on this. The hertz in the United States are 60 hertz, all right, whereas in Europe it's 50 hertz, all right. So what we're going to do is we're going to we can check the amperage first, okay. So what we do is we put this on amperage. I don't know if you guys could see this. So I'm going to bring it all the way up here. You see where the A is? The first A is AC and the second A is DC, just like the voltage. The first V is AC and the second V is DC. So we got AC right here, and we're going to just clamp it. You see where it says amps right there? Okay, so what we're going to do is we're going to clamp it on one of the phases. All right, and on this phase, it's only reading 2.9 amps. There's not really a lot going on right now. What's in this panel is, you see if 2.9 on this leg, right? And then if I move the other leg like this, this is a little bit more. This is 5.1 on that phase. All right. So what happens is we have a couple of different breakers in this panel. All right. This one is a 30 amp breaker. All right. It's a 2-pole, so that means you're getting 2 phases out of this. All right. Let me show you over here. All right, we're going to change this to voltage. All right. We're going to change it to voltage, which is the first V. All right. This is a fluke meter. There's all kinds of meters. You can get Klein. You can get all kinds of meters. They even have meters on TikTok that you can buy. But this is a good one. All right. I would recommend. All right. If you can, click like, subscribe to the channel. All right. There's a lot of knowledge here. I also teach a course to update you for your New Jersey electrical license. All right. So this chat room is good for people. This chat room is good for people that are DIYers. All right. Electricians, non-union and union electricians, apprentices, and New Jersey electrical contractors. So everybody can come in here and we can talk, you know. The thing is that with DIYers, they're afraid to come into the room because, you know, if they're doing basic stuff, they're just changing a light fixture or they're changing an outlet, and they're looking at videos like this and they're doing things the right way, that's okay. You know what I'm saying? But they can't do any new wiring. Any new wiring, you definitely need a licensed electrician. We know that for a fact. Okay? So if they want to change an outlet, that's their house. What are we going to do? You know what I'm saying? But just be safe about it. Make sure that you turn off the power, all right? And you check everything with your multimeter, all right? We also have a non-contact tester, all right? I have a fluke too. There's all different kinds. All right, I'm going to turn it back on again. And that will tell you if it's hot. Sometimes it gives a false reading. This is your best bet to test your stuff with, but this is quick, you know, and it may save your life. You know what I mean? So this will tell you if you have power here. Okay. So as far as this goes, we have a 30 amp 2-pole. All right. I'm going to shut it off for a second. I'm going to show you what it looks like. And just pull it out like that, and you'll see. I don't know if you guys can see it, but there's 2 different sides of the bus here. One goes to one phase, and one goes to the other phase, all the way down the line. They alternate like, okay? So that's how we get 240. This is happens to be a 120, 240 volt service. All right, so 240 is for your air conditioners, all right, or your blower units up in the attic, or your air condition. It could be air conditioner, or it could be a condenser outside for your AC, for your AC unit. All right, so we're just going to put that back. It just clips in there, and you push it, turn it back on. Okay, so also we're going to test voltage to make sure that each breaker is good and that each phase on the breaker is good. All right, so that's what we're going to do now. All right. All right, so like I said, we're going to go to the first voltage, which is the first V, which is AC. All right, and we got it, it's plugged in the bottom. One is the common, one is reads, this is how you read voltage. All right, you got your common and your other one. So right now we're going to do this. I'm going to hold this up like this, and we're going to go, we're going to go to the neutral. All right, so the neutral is the white right here. White is neutral, which is your return. All right, and we're going to test each breaker. I don't know if you can see that, guys. Let me see if I hold it this way. It's a little tight here. You know, there's not much room where the panel is. So we're going to test this one. You got 122. They're all on. Next breaker down, 121. Okay, that's a good reading. 116 to 123. That's a great reading. All right, so now we got right here 122. All right, next one down, 121. All right, part of this 2-pole breaker, which is a 2-pole 40. All right, it's 122 on that phase, 121, 122 on the next phase. This one is 122. This one is 122. 121, 122. This one is 122. This one is 121. All right, and then we go to the next size. Now this is a GFI breaker because we have a jacuzzi in here, all right? And it's protecting the jacuzzi, all right? So this is to protect you against, water, if any, it comes in contact with any water, so you don't get electrocuted, all right? So over here is the test button to make sure that it's working, all right? So when you reset a breaker, you always reset it all the way to the left, and then you turn it on to the right, okay? Now we're gonna go down, we're gonna test that one, first of all. That one's working, 122, all right? We're gonna go to the next one. That's 121. Then we're going to go to the next one of the double pole breaker, which is 122. The next one down is 121. The next one down is a single pole breaker. That's 122. Next one down is 122. The next one down is 122. The next one down is 121. So everything is working the way it's supposed to be working, okay? The next one down was the 30 amp again. So you got 122 on the one side, and you got 121 on the other side, okay? So everything is working the way it's supposed to be, all right? So my thing is, if you guys have any questions, you could bring it up in the chat right now, and I'll be happy to answer all your questions, as far as the sub panel goes. The sub panel comes off of the main panel, all right? When we go to the sub panel, we have the neutral and the ground go under the neutral bar, all right? Over here, when it comes up to the sub panel, or if the sub panel could be right next to the main panel, or it could be like here, about 75 feet away, all right? But what we do is we separate the neutral from the ground, all right, in this panel. And that has to be done, okay? Because in a main panel, you would have a ground screw that grounds the neutral to the frame of the panel, all right? Okay, so what we do is on a sub panel we separate the two, okay?
There's comments, Joe.
Okay, give me 1 second. Let me just check the comments.
You're gonna turn off the camera.
No, I'm just looking over here.
Okay.
Okay. I need a mirror for a second.
Hmm?
Okay. I need a mirror for a second. Okay. Okay, give me 1 second. Okay. All right, we're just checking on the comments. My iPad is not working too good. I'm getting someone to come by and give me a hand right now. But we're going to keep doing what we're doing. All right. So, like I said, these are 20 amp breakers over here. You can see the 20. These are single 20s. These are for, like, they could be appliance circuits. They could be for dishwasher or a microwave in a kitchen. All right. Any of the 20 amp circuits, or we're talking on the counter, you always have to have two different counter receptacles or small appliance receptacles. All right. So each one has its own circuit. All right, so that's maybe one of these 20s here. I have to look on the panel schedule because, you know, they should be marked the way they're supposed to be by code. All right, if you're going to get an inspection, your panel has to be marked. All right, if somebody's coming in there and they're just replacing a breaker or something like that, then, you know, that's different. But if you're going to upgrade your panel, it has to be marked, or else they're not going to pass inspection, you know. So let me take a look at this panel cover. And as you guys can see, nothing is marked, okay? That's not what I do. Everything has to be marked, okay? So, because in case of an emergency, you can't find something to turn it off, you know. All right, so let's continue. So we got we have a 15 here, a 15 here, single pole. All right, like I said, these are home line breakers. All right, they have a more square look to them, and they're made by Square D. All right, so this is a 15. This is a 15. That means that it could be general lighting, maybe in the living room. It could be general receptacles in the living room. Okay, nothing where it draws a lot. You know what I mean? Just if you're going to plug in a TV or a lamp or something like that, you know, those are what the 15 amp circuits are for. All right, so you're going to see a whole bunch of 15s and 20s, singles, and then, like I said, you have a 20 amp 2-pole here, which could be a 240 volt, because remember, each side is 120, so that makes it 240, right? So you may have a 240 blower in the attic. That's the reason why you might have a 2-pole 20. And then one of these is a condenser that's downstairs. Okay, this because it's a unit here. Now in these units, they happen to have electric stoves, all right? So the electric stove that they have here is a 40 amp stove, which is a number 8 wire, okay? What it is the 2-pole 40 right here. If you guys can see this one right here, 2-pole 40. And then this 2-pole 30 is for the actual condenser that's outside, that is for the air conditioner unit. All right. Okay. No. Yeah. Okay, Lotus. How you doing, Lotus? I'm looking at the comments now because I didn't have it before. Like I said, if you want to just click like and subscribe, if you can, to this channel. This channel is has a lot to do with you know, things that you can learn as far as electrical goes. All right, so you said how you test the amperage on a panel, and we just showed you that with the clamp-on meter. When should I use a clamp-on amp meter? So that's what we showed you. We showed you the amp meter, and we put it on amperage. Remember, guys? We put it on amperage. We put it on AC amperage, all right, which is the first A, and we put it over here, and we read the amperage on that phase, and we read the amperage on the other phase, okay? And then, like I said, you know, we could read the amperage over here, all right? And that's not, that stove is not on right now, so you're really not reading anything. Once I turn the stove on, that number will shoot up, all right? So that's how you can tell what it's drawing, if it's drawing too much, if the circuit has to be broken down, you know, maybe you have to run a new line to it. You know, like if there's too much on one circuit, sometimes that should be by itself, okay? But like if you have other circuits in there and they happen to trip your breaker and there's too much on there, sometimes you have to go into a junction box and you have to break up the circuit, okay? And like we talked about the voltage, we talked about plugging in the 2 leads on the bottom, all right, and then switching it to voltage, all right, over here, AC voltage, and then we were able to test. Our circuits. So if I go from here, remember, if I go from here to neutral, all right, we're going to have 122, all right. Like I said, if you have 2 phases, you have 120 and 120, that makes it 240, all right, in this particular situation. We have 120, 240, all right. So if I go on both sides of the breaker here, we have 240 here. You see that? So we have 240. All right. Let me see. Okay. So another thing is, if we were to take one of these wires off of here, this is a 15 amp. This is a 15 amp breaker, so that means it's a 14 wire. Okay. So I'm going to always shut it off before you take the wire off the breaker, obviously, all right? So we're going to take it off. I'm going to shut it off first. we're going to put our screwdriver in here and take off the wire like this. All right. Now, when you're changing, electricians, when you're changing panels out, the way to find out what size wire gauge it is, so you put on the correct breaker, all right? If you have yourself a stripper, a wire stripper, if you look here, you have two sides of the stripper, all right? Let me put my glasses on for a second. All right, so you have two sides of the stripper, right? So one goes from 10 to 18, and that's the solid side, all right? You have one that's etched in here in like a yellow lettering, okay? And then on the other side is the stranded side, so you'll have 12 to 20, all right? 12 being the largest, 20 being the smallest, and then on the solid side you have 10 being the largest, 18 being the smallest, all right? So if you could see right here. So when you go to strip that wire, all right, if you are in, let's say the solid side, because we're, excuse me, the solid side, because we're talking about solid wire here. We're not talking about stranded, all right? So if I take my stripper and I stick it in, I keep it closed, and I put it in 16, all right? Obviously it's not working. You see, it won't go through the hole. So that means that this is not a 16 wire. It's a little bit bigger, right? So the next size that we go up to after that would be 16. We go to 14, and you see how easy that is? It moves back and forth, okay? So that would be the size wire, all right? This is too big because you can see you're moving it around like this, back and forth. That's a 12 wire. So this fits perfectly into the 14. So when you go to strip it, that's the size you're going to be using. So this needs to go on a 15 amp breaker, all right? And this is, you know, a good thing that they put on the wire strippers also. And then if you notice, you have 632 and 832 screws on this, where you can screw the screw in, and you need, if you need to make it a little bit shorter, you put it in there, you close it, and it cuts it. All right, so this is a nice little tool on here. And then we also have you could also put in you could put a piece of wire in here like this in the hole over here, keep it at the very end, and then you just turn it like this, and then you could put it around a receptacle. Let me straighten that back out. If you're going to do electrical work, okay, on your house, you're going to change a fixture, like I said, fixture, receptacle, all right? Don't be doing anything that requires a permit, okay? If you do, then make sure that you do it right, all right? If you're a homeowner, let's say if you're a homeowner, you need a homeowner's permit, okay? Because it has to be inspected. You don't want to be sleeping in that house if it's not safe, you know? I would suggest you get an electrician because that's the right thing to do. But I understand that if you're a homeowner, you know, times are tough, you know. So anyway, we're just going to straighten this wire back out again so we can put it back under the breaker. And we're going to go, always go in the direction of the screw, even if it's a breaker. Whether you're doing a receptacle or a switch, always make sure the hook is going in the direction of the screw, because that's the way it tightens the best and it makes a better connection, all right? So what you're going to do is you're going to come in, we're coming this way with these because they're on the right side, so we're turning to the right, and then this one, okay, we're going to be turning to the right, but it will be on the it should be on the top of this, which you see how this one is over here is on the top, but he wasn't consistent. The electrician wasn't consistent when he went to go put his wires on here. It will still work, but it's not as great as the connection, you know what I mean? So over here, this is the proper way to go in. You're going to the bottom of the screw here because it's going to turn it around like that. you know, just make sure you strip enough. Make sure that you don't have any insulation underneath there. Hey, what's up? What's up, Glenn? How we doing? Hey, what's going on? All right, so we're gonna turn this nice and tight. I don't want to be all in front of that panel so you can't see it, you know. Giorgio, can you explain the difference between main lug subs and main breaker subs and when to use each? Yes. So we were talking about the sub panel, right? Which we had previously talked about. So this one happens to have a breaker in it, and the reason it has a breaker in it is because the distance. All right, this is about 75 feet to the main panel. All right, so that's the reason it's kind of like an emergency shut off, but it's not it's not bonded in the sub panel like a main breaker panel. Okay, main breaker panel has the green screw. It bonds the main breaker. This is not a main breaker. This is just a disconnect. All right, a form of a disconnect. It's a breaker in line. Okay, so this breaker is going to shut down this whole panel in case there's a problem. Like Giorgio said, if you could also have a main lug panel, all right? That would be good if the panel is close by, like maybe in the next room, or where you could really get to it fast, or next to the main panel, all right? It could have a main lug, all right? But in this case, you need another a disconnect in here. So this would be actually the sub panel breaker. It's not a main breaker, all right? Because there's no green screw in here. And we have to separate the neutral from the ground in this case. Downstairs in the main panel, like I said before, you have the grounds and the neutrals together, and everything is bonded to the frame. All right, over here, it's separated where the neutrals are separate from the ground. All right. What's up, Glenn? How we doing? So, Giorgio, so he's actually a union electrician, a friend of mine, a very good electrician. All right, so if you're in the room, you happen to be a homeowner or a DIYer, or you happen to be an apprentice, all right, if you need to ask him anything, Glenn is a good friend of mine, and he's also a technical teacher in the electrical school. He's very good. He knows his stuff. He's a great teacher. So if you're coming in here, these are good people, and you can learn from each other, okay? All right, so let's put that one back on, all right? If you're going to work in the panel, like I said, you really shouldn't. You should have an electrician work in the panel, but since you're a homeowner and it's your panel, okay, just be careful. Make sure you shut things off, all right? Make sure that you don't ground yourself. Make sure you always have one hand free, all right, so you don't complete the circuit, all right? Okay, so yeah, so this screwdriver that I have is like an 11-in-1 screwdriver. It's magnetic, okay, so you could flip your tips, whatever you got to do, you know, because I see a lot of homeowners and they have like just like, you know, the tools that you find on top of the counter in the hardware store. Those are really cheap ones. I mean, they work and everything, but these are better tools, you know. if you're going to do work all the time in your house, you know what I mean? But everybody, welcome to the room. Thanks for coming in. If you can, like, subscribe, and click on the channel, all right? And we'll be showing you a whole bunch of different things. We'll be showing you, you know, all kinds of electrical stuff, you know. And then we also have a class which is called Electrician's Masterclass, and we teach upcoming electricians to prepare for the New Jersey State license exam. All right, and it's at electriciansmasterclass.com. So with the GFI breaker, let me just take that out so you can see it. Always shut it off first. Pull it out with your one hand, all right? And what we have is, we have the neutral coming from the circuit, which is the jacuzzi again, I was telling you, all right? And then we have the hot wire. So the neutral goes in the back, okay? Neutral goes in the back. The hot goes in the front, okay? And then there's also a white wire that comes off of here. It's all looped around, all right? And that will go onto the neutral bar, all right? And that's how you wire up a GFI breaker. Back in, then you turn it back on. All right, like I said, this is the test button, all right, to make sure that it's working, all right. And so just be careful when you're doing things, you know what I mean? If you're not sure, ask somebody. Come into this room, ask me a question. I'm happy to answer before I see you get hurt, you know what I mean? So that would be good before before you do something, all right? Okay, let me see if there's any more comments. Okay. So like I said, we're going to be doing different things. We're going to be changing outlets, changing switches, and you know, we'll even take you on the job with me, and I'll show you a couple of different things. Right now, like I said, we're working on a sub panel, all right, and these are just the fundamentals of a sub panel and what it does, all right. Since this is residential, obviously, everything is Romex, you know, or SER cable, all right, which is the round cable. That's the indoor cable for service, which is aluminum, okay? The flat cable is the one that you put on the outside, and that's electrician's going to be doing that. That won't be you, especially if you're a DIYer. What's the difference between that and a double pole breaker? What's the difference between standard GFI and AFCI? All right, so GFI is for it's a ground fault, okay, and it's for wet locations. All right. The other one is an arc fault. Okay, so in case a lot of times people would put the wire behind a wall and they would wind up nailing a nail into the wire, and it would arc and it would start a fire. And what happens now is a lot of circuits that aren't like in wet locations or that have to be GFI are arc fault circuits. All right, this is all new construction, has to be put in when you're doing new construction. All right, as far as the old construction, that's considered rehab. All right, so most likely, unless you're going to do an addition or something like that, you're not going to need to change the breakers to arc fault or, you know, stuff like that. Arc fault is like definitely a new construction. All right, and it's in, you know, a lot of the areas of the house, you know, especially in the bedrooms and every place that you wouldn't put a GFI breaker, you know, like in, you know, the GFIs are for the garage, they're for the outside, they're for the bathrooms, they're for the kitchen, you know, stuff like that. So that's the difference between the two. We do have double pole GFI breakers. You know, say if I put in let's say a welder outlet, okay? If I put in a welder outlet and which I recently did, and that was in a garage, all right? It was an attached garage, so I didn't have to put a separate ground rod in, all right? So but I did have to put a GFI breaker in there because you know, it's in the garage, it's a wet location, you know. So that would be a 2-pole like this, but 2 with a GFI breaker, you know. So you got it, Lotus. If there's any questions you guys got, feel free, and I will answer them the best that I can. If not, I'll find the answer out for you. All right. But you know, I'm an electrician for 40 years, non-union and union, and so like I said, click like and subscribe to this channel, so we can help each other, you know. What's up, Sparks? How you doing tonight? Good to see you. Welcome to the room. Yeah, we're doing sub panels. All right, we're talking about sub panels today because we are in a unit that I'm working on. So we are we're talking about the sub panels. All right, and you know, if there's any questions you have about that. Yes, panels can support renewable energy systems like solar panels, you know. Usually that will come off your main panel though. All right, Lotus says here, them talking about single pole circuit breakers. Please explain what they are so I can join the conversation. So a single pole circuit breaker is just coming from one part of the bus, one phase. See, this is a phase, okay? So the buses, you know, the bus, there's 2 buses here coming down behind the panel here. So let me show you again. So if I take this breaker out and this breaker out, I don't know if you guys can see this, but if I take this out, you'll see that this one alternates. So this one would be every other one, and this one alternates on the other side. So that's the reason why you have two right here. So each one is a single phase or a single pole. All right, this is a single pole breaker. So if this was a tandem and I put this in, not a tandem. If I put this in and it was a double pole, that means that I would get 240 out of it because I'm getting two phases, 120 and 120. All right. So if I were just to put a single pole breaker in here, let's see if I can get it in there. Single pole breaker, that means that I would only be getting 120s, because if I go from here like we did with our tester before, if I go from here to the neutral bar, we're only getting 120. All right. So let's put these back. Okay, so that's back there. All right. But I appreciate the questions. Whatever questions you can, just bring them in, so we can make this knowledgeable for a lot of people, whether it be DIYers or aspiring apprentices that are learning in the trade. Electricians are welcome, non-union and union electricians, and licensed electrical contractors like myself. And you know, we all get together and you know, don't just pick my brain, pick their brains too. All right, because they have a lot of information, you know, and they're very, very good and talented, you know, like I mentioned before. How do you test amperage on a wire in a panel? When should I use a clamp-on meter? Okay, so again, with the this is the clamp-on meter. This is a clamp-on meter here, and you have to take the leads out for that, and you would put it on amperage up here, right here, which is the AC amperage. Remember I told you the first A is the AC amperage, and then the second A is the DC amperage. All right. So you'll test your amperage. Okay. So let me put it around one of these leads here. Okay. So now you can see it's not reading anything. You can see it, right? I don't know if you guys could see it. Could you see it? Can you put a breaker in with larger amperage than the main? No, that's a good question, Giorgio. I wouldn't suggest you do that. No. No, I would keep the main the way it is. I wouldn't put a larger breaker in the main. No. But like I was telling you about this, the amp meter here, okay? It's not reading anything because it's a stove, okay? So could you actually see the what it's reading over here? It's not reading anything because the stove is not on right now. So I'm going to just turn the stove on and see if it goes up. All right, so let me do that. All right, so let's see if it moves. All right, as you can see, it went up to 24.7. You see, once I put the burners on the stove on, the electric stove. So that's how you read your amperage here. All right, now we're on a 40 amp breaker. All right, we should be fine. Now if that goes up higher, and it goes higher than 80%, and it starts going to like 40 amps, it's going to trip. You know what I mean? It's going to get hot. It's going to trip. It's, you know, and that's what's going to happen. All right. And as it gets hotter, you know, it will keep changing and fluctuating, you know. So that's what the amp probe is for. So let me shut that off. Okay. You're having an issue choosing the right setting overall. Can you give me the basic setting for what you're doing now? Now, what do you mean the right setting? What are you talking about, the right setting? The setting of what? Oh, choosing the setting on the amp probe, we had just talked about that. We're going to use the clamp right here. You always use the clamp when you're using the amp probe, all right? And we're on AC, not DC. So yeah, the basic setting would be just to put it on AC, which is right here. Okay, you see it, AC? And then we just clamp it around one of the legs, one of the phases of whatever you're going to test here, which is the stove, all right? So right now, like I said, it's not really doing anything because the stove is not on. All right, I'm just choosing the right thing. Okay. Like I said, okay, if my amp probe doesn't have a clamp or opening, can I use the meter leads? Oh no. What they do is they have these amp probes and they have a external clamp that you could put on here if you don't want to be right up on it, you know. If you want to be like right here and clamp it into your meter, and then you can be a little bit further away. It's just a safety thing. But you're going to use the claw. You're going to use the clamp most of the time, you know. But that's a good question, though. All right, is it common to have issues connecting the probes? This is where I always get stuck. Well, I mean, as far as connecting the probes, they're color-coded right here. So, right here, so you know we're doing voltage. So you're just going to put the common, which is the common in this case is the black, and then this reads volts. Right here, I'm sorry, you have the common over here, which is the black, all right? And then you have the volts on the other side. So this is going to read voltage if you put those in. So we have red here, all right? It's one of our leads. We just push it in the bottom. Then you have the black here. We push that in the bottom, all right? And this is going to read our voltage again. So I had it over here before, and say if I put it into my neutral, the one lead into my neutral, I don't know if you guys can see this. Hold on one second. I have nothing really to hold it, to clamp it to. All right, so anyway, so if I put the one in here, let me hold the clamp like this. We'll put the one on a neutral bar, and then one of the phases, one of the breaker phases here, okay? And just make sure that you're on the right setting here, because I was on amperage. So we're going to bring it back down to voltage over here, AC voltage, all right? One lead is in the neutral bar, and then one lead is on one of the breakers, okay? Oh, my lead came out. Hold on. Okay, lead came out. Just make sure both your leads are plugged in before you do anything. All right. Sometimes they have a tendency to fall out. All right. So you got the neutral on one side here, and then, like I said, my breaker here, and then you get the 121. You see that? We got our 121. All right. Now the panel is not, Sparks, the panel is not the same thing as a fuse box. We used to have fuse boxes where the fuses would work like the circuit breakers, but they would blow out and then you'd have to replace them. So when this breaker gets hot circuit, then you have to find a problem. Connecting the pros, get that. Okay. All right, so that's that. Now also we can read what we call continuity. All right, if we want to make sure that there's not a break in the wire, all right, and I want to test one side of the wire, okay, on one end say it's like say it's a 2-wire, right? So what I'll do is I'll test, I'll put this on the black wire. I'll put this on making sure that it's not live, that it's just sticking out of the wall. All right, we want to test it, make sure that the cable is good. So we'll put this on one side, on the black wire, on the white wire, okay? And then what I can do is, if there's an outlet in there, I can either pull the outlet out and then put like a wire across, or connect them together, all right, under a wire nut, or we could just put a wire in the outlet, as long as it's not live, all right, because I'm just testing for continuity that there's not a break in the wire. So if the wire is good, we're going to hear that noise, all right? All right? That means that the wires are together, everything is good. And then once you take that wire out of the outlet, the noise will stop, all right? So that's how you could check continuity, all right? What this meter also does. Now, what do you mean, Lotus, when you say, how do you know if there is a loose connection at the terminal? What do you mean by that? Sometimes you do have a loose connection. You know, you might have a loose connection at the outlet, all right, which is going to spark, it's going to arc, it's going to cause a fire, it's going to burn the outlet, all right? So make sure all your connections are tight, your splices are tight. When I make my splices, I make sure that, especially solid wire, or any kind of wire, that I always twist them together. Don't listen to what the wire nut says. If you go to buy it in the store, it says you can put it underneath there and just twist it. That's not a good connection, all right? Some people use what we call Wacos. They're little, they look like little suitcases, and you stick the wire in it. The tension holds it together. Those are good too. They're more expensive. I like wire nuts. I think they're a better connection. What the sound would be, I think that the sound is a little annoying. Becky. See, I like the sound. Sometimes continuity testers might have just light, but if you're at one end of the basement and it's pretty quiet, you could hear the noise from the meter, and you know, it helps you find the circuit. You know what I mean? All right, so we're gonna, let's see, what we're gonna do is we'll keep the room open for a little bit, you know, if you have any other questions. I think the sound, yeah, I mean, the sound could get annoying after a while, you know. It's just like when you go to test to make sure there's power, you know, when you go to turn a circuit on and off, that noise would annoy you too, but sometimes you have to have that there so you can hear it, especially if you're like the floor above, you know what I mean? So that's why I like the audio part of it, you know? All right, so what we're gonna do is I'm gonna put the panel cover on, and you guys can still ask questions. All right, I'm going to show you how to put the panel cover on and how to do it safe. All right, let's make sure that breaker is tight. All right, so we're going to put this panel cover on. Always make sure that you hold the panel cover when you do it, that it doesn't, you know, fall back into the panel to hit anything that's going to short, you know. All right, so let's put that there. All right, so you see how I'm holding it with the one hand, and then we screw it on. All right, like that. And like that. And make sure you got all 4 screws. You could always get extra screws at Home Depot. They sell them separately. Oh, Sparks, how can a homeowner safely access a panel? I usually look at the stuff in the house and I don't. You don't want to get shocked. You just have to be careful what you do. Like I said, don't ground yourself. But like say for a sub panel, if you want to work on the sub panel, you can go down to the main panel. All right, if you're working on a sub panel, let me get the last screws in here so I don't forget. So in the main panel, you should have a breaker that feeds the sub panel. So turn it off, it will kill this whole panel. You can do whatever you want to do with this panel, and then when you're ready to turn it back on, all you have to do is turn the main back on. So that was a good question, Sparks, and that's what you would do with that. How are some ways a person can actually ground themselves? I want to definitely make sure that I don't do that. Well, if both hands are in the panel, you're going to complete the circuit. You know what I mean? So you just have to watch that you don't ground your one hand ground the panel, because you're touching the metal. That's the ground, all right? So you don't want to ground yourself to the ungrounded conductor or the hot wire, all right? You're going to get shocked, all right? So that's why I say always try to use one hand if you can. I'll wear rubber Crocs for messing with the electricity. Is there a recommendation shoe for electricians? Yeah, electrically insulated soles. That we have. There's different boots that electricians use that work pretty good. Red Wing makes a particular one that grounds you, that insulates you, and grounds you from getting shocked, but you have to still be careful. That's not going to totally protect you, you know what I mean? It's going to help you a little bit, yes, there's special gloves that you can get. You can get high voltage gloves. Electricians use them all the time. What is the limit a homeowner should do inside a panel for safety? Oh yeah, that's a good question, Giorgio. So what I would do is, like I said, make sure you shut off that main panel. Make sure you shut off that main panel wherever it is. It could be right next to this one in some cases, or some cases. In this case, it's like about 75 feet away, which is in the panel room downstairs, all right? So shut that off. That will kill this, and then you can work on it safely, all right? So that's how a homeowner, actually, you shouldn't be doing your own work in a unit, in a condo or an apartment, all right? You shouldn't be doing your own work, all right? Now, if it's your house and you want to do your own work, there's really, the only way that you can safely do it is to cut your main off in your panel, and then everything below that is going to be off, all right? So then you could work on it like that. But that's a great question, Giorgio, all right? You worked in Crocs. Foremen don't quite like that. Yeah, I hear that. I've seen people working crazy. They work in sneakers. The best thing to do is, if you're an electrician, wear the boots. Definitely wear the boots, all right? That's going to protect you, but you also have to be careful too. All right, I wear children's size shoes, and I want to know if maybe Red Wing makes them in any size. I don't know. It's kind of embarrassing. Yes. I'm sure you can get any size that you want to get. I don't know what they start at. That's a good question. No doubt, Sparks. Thanks for dropping by. If you could subscribe, click on and subscribe to the channel. We can learn a lot of stuff. But like Jojo was saying, once you cut this breaker off, all right, this is going to cut down the whole bus, all right, which is where all these breakers are, all right. So this main is going to cut down this whole thing, and then if you want to change any of these breakers, all right, if you're a homeowner, okay, and you're going to change the breaker, make sure you shut the main off, okay, and then anything below that will shut off that panel, all right. It's just that you got to be careful around this breaker on the top because it's still live. So that's basically it for the panel. The next time that we'll be going live will be Thursday night, and we'll see what we're gonna do. We might work on an outlet or something like that, or you know, we're just gonna, you could always bring your questions in, and then this way we can all chat together. All right, you guys, thanks for coming in. Like I said, like, click, subscribe to the channel, Electrician's Masterclass.